Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore Amazon Data Firehose, which was formerly known as Amazon Kinesis Data Firehose. This is AWS's fully managed service for reliably loading streaming data into data lakes, data stores, and analytics services. We'll cover the core concepts, architecture, and use cases of Firehose, and how it integrates seamlessly with destinations like Amazon S3, Redshift, and OpenSearch. Let's get started. As organizations embrace data-driven strategies, one of the first hurdles they encounter is the complexity of delivering data reliably, at scale, and in real time. Data volumes are exploding. Whether it's application logs, user interactions, IoT sensor streams, or transactional events, the velocity and volume of incoming data continue to grow exponentially. This data is often most valuable the moment it's created. Businesses want to analyze it immediately to detect anomalies, personalize experiences, or trigger operational actions. That demand for near-instant insights creates significant pressure on engineering teams to build pipelines that can process and deliver data with minimal delay. But setting up these pipelines isn't trivial. Traditional approaches often involve a patchwork of components: message brokers, custom ETL scripts, buffering layers, and various transformation tools. Each adds complexity, operational overhead, and potential failure points. Maintaining reliability and performance across such systems becomes an ongoing challenge. At the same time, there's a growing need for simplified ETL to enrich, filter, or reformat data as it flows through the pipeline without introducing latency or compromising throughput. These pipelines must also scale elastically with traffic spikes and provide durable delivery, ensuring no data is lost, even in the face of outages or downstream unavailability. Finally, integrating these pipelines with diverse data stores, such as S3 for lake storage, Redshift for analytics, or OpenSearch for search and observability, adds another layer of engineering effort and complexity. Together, these challenges highlight the need for a fully managed, scalable, and resilient streaming data delivery solution. And that's exactly where Amazon Data Firehose comes in. Amazon Kinesis Data Firehose is a powerful, fully managed service designed to take the complexity out of streaming data delivery. It enables organizations to reliably and effortlessly load real-time data into storage and analytics destinations, all without needing to manage infrastructure or write custom ingestion pipelines. One of its biggest advantages is that it's a zero administration pipeline. That means no servers to provision, no clusters to tune, and no ongoing operational work. Firehose takes care of it all, from data ingestion to buffering, batching, and delivery, so your teams can focus on analyzing the data instead of wrestling with the mechanics of moving it. As your data volume grows, Firehose automatically scales behind the scenes to match your throughput needs. Whether you're streaming a few thousand events per minute or hundreds of megabytes per second, Firehose adjusts dynamically, maintaining performance and reliability without intervention. But Firehose is more than just a conduit. It offers built-in data transformation capabilities through AWS Lambda integration. This lets you enrich, reformat, or filter data on the fly as it flows through the pipeline. So instead of waiting for downstream systems to clean and reshape the data, you can deliver it in the right format, right from the source. Under the hood, Firehose is engineered for reliability and durability. It guarantees at least once delivery and automatically retries failed deliveries. And if needed, you can back up all incoming data to Amazon S3 before any transformation or delivery, ensuring nothing is ever lost. Finally, Firehose operates with a pay-as-you-go pricing model. There are no upfront costs or long-term commitments. You only pay for the volume of data you process and any optional transformation or format conversion. That makes it accessible and cost-effective whether you're a startup handling gigabytes or an enterprise managing petabytes. Here we have an illustration of the Data Firehose architecture. On the left, we begin with a diverse set of data producers. These could be web and mobile applications generating clickstream data, IoT devices streaming telemetry, back-end services emitting logs, or other data pipelines producing events in real time. Each of these sources creates structured or semi-structured records that need to be captured, processed, and stored, often within seconds of their creation. All of this streaming data is directed into Amazon Kinesis Data Firehose, which serves as a fully managed ingestion and delivery layer. Think of Firehose as a smart, dynamic buffer. It doesn't just accept data, it temporarily holds and processes it, applying buffering, optional transformations, and formatting rules, ensuring that data is correctly shaped and timed for delivery. Once inside Firehose, each record is evaluated against configured parameters such as buffer size and interval. If needed, data can be transformed on the fly using AWS Lambda, for example, enriching it with metadata or converting formats like JSON into Parquet or ORC for optimized analytics. From there, Firehose routes the prepared data to one or more destinations shown on the right side of the diagram. For scalable object storage, it delivers data to Amazon S3. For interactive querying, it can send data to Amazon Athena. If you need real-time analytics over structured data, Amazon Redshift serves as the data warehouse target. And in some cases, the data might even be routed into Amazon DynamoDB to support low latency, NoSQL applications. Each of these endpoints enables downstream systems to query, visualize, and act on the data in near real time. Whether it's powering a dashboard, triggering alerts, or training a machine learning model, Firehose ensures that data moves from producers to consumers reliably, efficiently, and securely. It's important to understand its core architectural concepts, the building blocks that define how it operates and delivers streaming data at scale. At the center of Firehose is the delivery stream, the primary resource that represents the full pipeline from ingestion to destination. Each delivery stream is configured with a specific target, such as Amazon S3, Redshift, or OpenSearch, and includes all the necessary settings for buffering, transformation, and delivery. A key performance tuning lever in Firehose is the buffer size and buffer interval. Since Firehose batches data before delivery, you can configure how much data to buffer, anywhere from 1 to 128 megabytes, and how long to wait before delivering it, from 60 to 900 seconds. This gives you control over delivery latency versus throughput efficiency. Firehose supports record format conversion from incoming JSON data to Apache Parquet or ORC on the fly, leveraging your AWS Glue data catalog to apply schema definitions. This significantly improves query performance and reduces storage costs in systems like Amazon Athena. If your use case requires transforming or enriching data before it's delivered, Firehose integrates seamlessly with AWS Lambda. You can plug in a Lambda function to modify, filter, or add context to each record as it flows through the stream, enabling powerful real-time ETL. Reliability is a cornerstone of Firehose, and that extends to its error handling and retry mechanisms. It also exposes detailed CloudWatch metrics and error logs to help you monitor and troubleshoot delivery pipelines proactively. To optimize storage and transmission, Firehose supports compression options such as gzip, zip, and snappy. This can reduce storage costs and improve data throughput for downstream analytics systems. Finally, it's essential to be aware of service quotas and limitations. Firehose enforces limits on things like the number of delivery streams per account, maximum record size, and throughput per stream. While these limits are generous by default, many can be increased through AWS support to accommodate enterprise-scale workloads. Buffering is the mechanism that allows Firehose to collect incoming streaming data and deliver it to the destination efficiently. This buffering is governed by two key parameters: buffer size, measured in megabytes, and buffer interval, measured in seconds. Firehose initiates a delivery to the configured destination when either the buffer size threshold is reached or the buffer interval elapses, whichever comes first. For example, the default configuration for Amazon S3 and OpenSearch destinations is a 5 megabyte buffer size or a 300-second interval, meaning data will be delivered as soon as either 5 megabytes is accumulated or 5 minutes have passed. These defaults can be modified based on your workload and the destination you're delivering to. Some destinations like Amazon Redshift have smaller maximum buffer sizes, typically around 4 megabytes, and may require shorter intervals due to the nature of database ingestion. Choosing the right buffer size and interval involves a trade-off between latency and cost efficiency. Smaller buffer sizes or shorter intervals result in faster delivery, reducing latency. This is critical for real-time applications where timely access to data is a priority. However, this can also lead to more frequent delivery attempts, potentially increasing your operational costs. On the other hand, larger buffer sizes and longer intervals can improve delivery efficiency by reducing the number of delivery calls. This leads to fewer, larger batches, which can be more cost-effective, especially when delivering to destinations like Amazon S3 or Redshift, where larger files can optimize downstream processing performance. For burst-heavy or sporadic workloads, buffer settings may need to be adjusted to avoid delivery delays. If the buffer size is too large and data arrives in short bursts, Firehose may wait too long before delivering, impacting time-sensitive workflows. Buffer settings also affect data transformation. If you're using Lambda functions to transform data before delivery, the transformation only occurs when the buffer triggers a delivery. Therefore, inefficient buffer configurations can delay both transformation and delivery, affecting the timeliness of insights. At the core of this functionality is record transformation using AWS Lambda. With just a few lines of code, you can invoke a Lambda function to process each record in real time. This means you can reformat fields, apply business rules, mask sensitive information, or even enrich the record with data from external sources, all as the data flows through Firehose. Firehose's transformation capabilities go further by enabling filtering and aggregation. If certain records are not relevant for downstream processing, you can discard them during transformation. You can also implement logic to combine records into more meaningful aggregates, reducing the load on your analytics tools. You can also perform data enrichment by adding metadata, geoinformation, or reference data during transformation. This enables deeper insights without requiring changes to the original data source. In addition to Lambda-based transformations, Firehose offers native format conversion, allowing you to automatically convert JSON records into columnar formats like Apache Parquet or ORC. These formats are ideal for data lake environments, significantly improving the performance of downstream tools like Amazon Athena, Redshift Spectrum, and AWS Glue. When delivering data to Amazon S3, Firehose supports dynamic partitioning, a powerful feature that routes records into specific S3 prefixes based on values within each record. For example, you can automatically group records by date, region, customer ID, or any custom field, making your storage more organized and your queries more efficient. These capabilities unlock a wide range of use cases, from reformatting web clickstreams for Redshift, enriching IoT data with device metadata, to transforming logs for search engines or dashboards. Data Firehose is designed to handle automatic throughput scaling. As your incoming data volume increases or decreases, Firehose adapts behind the scenes to accommodate the change. This means you don't need to worry about partition keys or manually adjusting capacity like you would with other streaming services. One of the key benefits of Firehose is that it completely abstracts shard management. There's no need to provision or manage shards, no resharding logic, and no complex scaling strategies. Firehose simplifies the experience by managing the elasticity for you. At the heart of its scaling capabilities is elastic buffering. Firehose uses a combination of buffer size and time interval settings to accumulate data before delivering it to the destination. These buffers are not static, they flex to match the volume and velocity of your data, ensuring efficient batching and delivery. You can fine-tune these parameters, but Firehose is smart enough to adjust dynamically for high-throughput pipelines. Firehose is built to support high-throughput use cases, capable of handling gigabytes of data per second. Whether you're streaming telemetry from millions of IoT devices or ingesting clickstream data from web applications, Firehose scales automatically to meet the demand without interrupting data flow. Another strength of Firehose is its ability to handle multiple concurrent producers. Applications, mobile devices, AWS services, and third-party integrations can all send data to the same delivery stream concurrently, with Firehose efficiently managing the load without creating performance bottlenecks. When paired with auto-scaling destinations, such as Amazon S3, Redshift, or OpenSearch, Firehose plays nicely with your broader data infrastructure. As these services grow to meet their respective demands, Firehose continues to deliver data seamlessly, helping maintain a scalable end-to-end pipeline. And finally, Firehose includes built-in retry and error handling, which allows the service to respond gracefully under pressure. If delivery to a destination fails temporarily, Firehose automatically retries, scaling its delivery attempts without data loss. Amazon Kinesis Data Firehose is built with enterprise-grade protections that help you safeguard your data, meet regulatory requirements, and maintain trust with your users. One of the foundational aspects of Firehose security is its support for end-to-end encryption. Data is encrypted in transit using HTTPS, ensuring that records cannot be intercepted as they move through the network. Once at rest, data can be encrypted using AWS Key Management Service, allowing you to manage your own encryption keys and control access down to the stream level. Access to Firehose resources is tightly controlled through AWS Identity and Access Management. This allows you to define precise, role-based policies that govern who can create, update, or delete delivery streams, invoke transformation functions, or access the data in its destination. For even greater isolation and protection, Firehose supports virtual private cloud integration. This means Firehose can deliver data directly to destinations inside your VPC, such as Amazon S3 buckets or Redshift clusters, without exposing traffic to the public internet. Access to destination resources, like S3, is further secured using fine-grained bucket policies. These policies let you tightly control which IAM identities, VPC endpoints, or AWS services can read from or write to specific paths, ensuring that data remains protected once delivered. Firehose is also covered under major AWS compliance programs, including SOC, ISO 27001, HIPAA, and PCI DSS. This makes it suitable for handling sensitive and regulated data, giving you peace of mind that your streaming infrastructure adheres to industry standards. In terms of governance, every API call made to Firehose is logged via AWS CloudTrail, providing a complete audit history of all configuration changes and access attempts. Whether you need to investigate unusual activity, maintain change logs for security audits, or demonstrate compliance during assessments, CloudTrail ensures traceability at every step. Amazon Data Firehose makes pricing easy with a simple, pay-as-you-go billing structure that scales automatically with your data volumes. At its core, Firehose pricing is based on the volume of data ingested into the service. This volume is measured in gigabytes of uncompressed data, so whether your records are compressed before delivery or not, you're billed based on the raw size of the data as it enters the stream. This model ensures transparency and consistency, regardless of downstream optimization. Firehose includes data delivery to Amazon S3 at no additional charge beyond the base ingestion cost. However, if you're delivering data to other destinations like Amazon Redshift or Amazon OpenSearch, there may be additional delivery fees. These charges account for the orchestration and integration work Firehose performs to reliably deliver data to these services. If you enable record transformation using AWS Lambda, you'll incur standard Lambda charges for each invocation. This includes both the number of times your function runs and the compute time it consumes. While powerful for filtering, enrichment, or reformatting, Lambda-based transformations should be designed efficiently to keep costs in check. Another optional feature is format conversion. Firehose can convert incoming data from JSON into columnar formats like Parquet or ORC, which are optimized for analytics and storage. Enabling this feature incurs a per gigabyte processing fee, but the benefits can be substantial. Columnar formats reduce data footprint and significantly accelerate performance in downstream services like Amazon Athena or Redshift Spectrum, ultimately saving you money in storage and query costs. Also keep in mind that region-specific pricing applies. The cost per gigabyte can vary slightly depending on which AWS region your Firehose stream operates in, so it's always a good idea to check the latest pricing information on the AWS website for your specific geography. Amazon Kinesis Data Firehose offers a fully managed way to deliver streaming data. But like any scalable service, cost optimization becomes crucial as data volumes grow. One of the simplest ways to optimize cost is by tuning the buffer size and interval settings. Firehose batches records before delivering them to the target service. by adjusting the buffer size up to 128 MB or increasing the buffer interval up to 900 seconds, you can reduce the number of delivery operations. Another impactful tactic is to enable format conversion, such as transforming JSON records into Parquet or ORC. These columnar formats are far more efficient for storage and analytics, dramatically reducing your S3 footprint and accelerating queries in Amazon Athena and Redshift Spectrum. Firehose also supports compression, including zip, and snappy, which can shrink data size before it's stored or forwarded. This is especially valuable for high-volume pipelines where raw data storage can grow rapidly. Enabling compression helps save on both storage and transfer costs. You can also reduce costs upstream by filtering or aggregating records using AWS Lambda during transformation. By removing irrelevant data or combining multiple events into a single record, you can decrease the volume of data that needs to be stored or processed downstream. Be mindful of how your data destinations are provisioned. If you're sending data to services like Amazon Redshift or OpenSearch, ensure that your clusters are appropriately sized based on the actual delivery volume. For long-term storage, use S3 lifecycle policies to automatically transition data to lower-cost storage tiers like Glacier or intelligent tiering. This ensures that your older, less frequently accessed data is still retained without incurring high costs. Finally, consider consolidating delivery streams where possible. Instead of managing multiple streams for similar types of data, you can use tagging or dynamic partitioning to route data through a single, well-configured stream. This reduces management overhead and avoids redundant processing charges. Amazon Kinesis Data Firehose offers several powerful tools that allow you to observe, understand, and react to what's happening in your delivery streams, all without adding significant operational burden. At the core of Firehose observability is its integration with Amazon CloudWatch metrics. Firehose automatically emits a comprehensive set of metrics that capture the volume, throughput, and status of data flowing through your delivery streams. To take it a step further, you can create CloudWatch alarms based on these metrics. This allows for proactive monitoring and ensures that issues are caught and resolved quickly, often before they impact downstream applications or data consumers. Another important layer of observability is provided through Amazon CloudWatch logs. Firehose can be configured to log delivery attempts, transformation errors, and format conversion failures. This deep logging capability is essential when debugging or analyzing delivery patterns. Delivery stream level monitoring provides further granularity. Each Firehose delivery stream is independently instrumented, allowing you to drill down into metrics and logs specific to that stream. This is especially useful in environments with multiple data pipelines serving different purposes or workloads. When you're using AWS Lambda for record transformations, Firehose integrates seamlessly with Lambda's own monitoring framework. If there are issues related to execution time, memory usage, or invocation failures, these are logged automatically, allowing you to fine-tune your functions or adjust buffering parameters as needed. Beyond native AWS tools, Firehose also supports third-party monitoring integrations. Metrics and logs can be forwarded to observability platforms like Datadog, New Relic, or Splunk. This enables centralized monitoring across hybrid environments, where your operations team may already have established dashboards and alerting mechanisms in place. And for compliance and security use cases, AWS CloudTrail records all Firehose-related API calls. Whether someone creates a new stream, modifies a destination, or changes buffering settings, it's all logged and auditable, ensuring traceability across your organization's data infrastructure. Let's explore some of the most common scenarios where Data Firehose can provide significant value. One of the primary use cases for Data Firehose is real-time log and event data ingestion. Whether you're gathering logs from applications, servers, or network devices, Firehose enables you to seamlessly stream this data to destinations like Amazon S3 or Amazon Elasticsearch Service. This allows for real-time log aggregation, monitoring, and analysis. Clickstream data analysis is another area where Firehose shines. By streaming web application clickstream data directly to platforms like Amazon Redshift or OpenSearch, businesses can analyze user behavior in real time. This data is invaluable for deriving insights that drive better user experiences, targeted marketing strategies, and personalized content recommendations. For Internet of Things IoT applications, Firehose provides a way to aggregate and process data from millions of connected devices. Whether you're capturing telemetry data or sensor readings, Firehose can stream this information into Amazon S3 or Amazon Redshift for further analysis and operational insights. Data Firehose also supports real-time data transformation and format conversion. If you need to convert data from JSON to formats like Parquet or ORC before delivering it to downstream destinations, Firehose allows you to do this in real time. Another common use case is building data lakes. Firehose simplifies the process of ingesting large-scale raw data into Amazon S3, where it can be stored and organized for downstream processing. This is especially useful for companies building data lakes, as it allows them to efficiently centralize and structure their data, making it available for further analysis with services like AWS Glue and Amazon Athena. Lastly, Firehose can play a critical role in machine learning data pipeline integration. Cleaned and structured data can be streamed into Amazon S3 or Amazon Redshift, where it becomes an input for training machine learning models or generating real-time predictions. This is a crucial step for businesses leveraging machine learning for everything from fraud detection to personalized recommendations. When evaluating streaming data solutions on AWS, it's important to understand the distinct roles that Amazon Kinesis data streams and Amazon Data Firehose play in real-time data pipelines. Amazon Kinesis data streams is designed for real-time streaming data processing with low latency requirements. It's built for highly customizable use cases where you need control over how data is consumed, processed, and distributed. With data streams, you manage the flow of data through shards, a unit of scalability, and are responsible for managing shard capacity, scaling based on your throughput needs, and configuring data retention, which can extend up to 365 days. In contrast, Amazon Data Firehose is a fully managed service that simplifies the delivery of real-time data to destinations like Amazon S3, Redshift, and OpenSearch. With Firehose, you don't need to worry about shard management or scaling. The service automatically adjusts to accommodate incoming data. Firehose is ideal for scenarios where you want to quickly stream data with minimal configuration and management overhead, and you're focused on data delivery rather than complex processing. Another key difference is in the area of data transformation. While Kinesis data streams requires you to build custom data processing applications using services like AWS Lambda or EC2, Data Firehose allows you to apply real-time transformations using Lambda without the need to set up complex applications. This means you can easily filter, enrich, and convert data formats, e.g., from JSON to Parquet, on the fly. In terms of scaling, data streams requires manual intervention. You must configure and manage the number of shards required to handle your data's throughput. On the other hand, Data Firehose scales automatically based on the volume of incoming data, making it much easier to handle spikes in traffic without worrying about resource allocation. Both services offer error handling capabilities, but with Firehose, retry logic and automatic error handling are built in, allowing the service to handle transient failures without manual intervention. Data streams, by comparison, requires custom error management strategies. In short, Kinesis data streams is ideal for custom processing and low latency data applications, while Data Firehose excels at simplified, fully managed delivery with automatic scaling and built-in transformations. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.